Good morning. Today we're going to start with Module 4, Lesson 9, Input-Output Tables. Students are to complete an input-output table when given a function rule. Let's start out today with our academic vocabulary. This is something that you all should have learned from your vocabulary you did at the beginning of the unit. What is the function rule? The function rule, an equation that shows how an input value x and an output value y are related. What is a function? A function, a pairing of input and output values in which each input value is paired with exactly one output value. Independent variable. An independent variable is a variable that represents the input value. The dependent variable is the variable that represents the output value. An input-output table is a table that shows how an input value x is paired with an output value y. So let's get started. We are on Module 4, Lesson 9, which is page 31 in your student books. Let's look at problem 1. The expression x plus 5 contains the variable x. In the problem 1a, substitute -1 for the variable and evaluate the expression. So we're going to substitute give me just 1 second here, guys. Let's get this pulled down where we can see it. There we go. Now I'll get my pen back. So now we are going to substitute -1 for x in our equation x plus 5. So we will put -1 here. So what is -1 plus 5? What is -1 plus 5? We know that we are adding unlike signs. Therefore, we subtract the smaller from the larger and keep the sign of the larger. So 5 minus 1 is 4. The sign of our larger is indeed positive. So our answer is 4. In problem 1b, we're going to substitute 1 for the variable and then evaluate the expression. We will substitute 1 here. Now, x plus 5 equals 1. What is 1 plus 5? We're adding like signs now, so we simply add and keep the sign. So our answer is, our solution is 6. So what is the, Now let's look at problem 2. What can we do with this type of information? Okay, look at the function y equals x plus 5 in the table in problem 2. A function rule is an equation that shows how an input value x and an output value y are related. The variable that represents the input value is called the independent variable of the function rule. The variable that represents the output value is called the dependent variable of the function rule. The table in problem 2 is called an input-output table. An input-output table shows how each input value x is paired with an output value y. In the table, there is a column for the x values, the input values, a column for computing the output values, and a column to write the output values, the y values. Use the function rule y equals x plus 5 to find the output values that are related to the given input values. So if we look at the first one in the table in number 2, it says that x is -1. So y equals, our original function was what? Y equals x plus 5. So we substitute -1 where there's an x. So now we have the equation y equals -1 plus 5, which equals 4. So our output value, as you can see right here, is 4. If we input 1 for x, our equation then becomes y equals 1 plus 5, which equals 6. Therefore, our output value, or our y value, is 6. Next, we're going to input 3 for the x value, and we have what? Y equals 3 plus 5, which equals 8. Therefore, our output value, or y, is 8. If we input 5 for our x value, we substitute that for x in our equation, as we've done with all the rest. Y equals 5 plus 5. Therefore, y equals 10. So our output, or our y, is 10. So as you can see, just as we've done in the past, when we have an equation and we're given a value for our variable, in this case it would be we are evaluating y equals x plus 5 when x equals -1, 1, 3, or 5. We're substituting those values for x and solving our equation, just as we've done in the past. This will give us our y value, as you see here, which is our output. Now let's look at problem number 3. Scroll up here where we can see it a little better. Problem 3. The function rule for this input-output table is y equals x minus 4. Look at the row of the table for x equals -2. When x equals -2, the value of y is -2 minus 4. What is -2 minus 4? Well, once again, we are subtracting, right? So what do we do with subtraction? We change subtraction to addition of the opposite. We change subtraction to addition of the opposite. So our equation becomes, let's handwrite this where you can see it. Our equation becomes this. It becomes -2 plus the opposite of 4 is -4. Okay? So now we're adding like signs. We have -2 plus -4. So what do we know about adding like signs? We just simply add them together, add the numerals together. So 2 plus 4 is 6. We keep the sign, which is negative, so our output should be -6. Okay. -6. So the output value is -6 when the input value is -2. Well, let's take a look. If x equals 0, if we put 0 for x in our equation, then y is 0 minus 4. What is 0 minus 4? Once again, we turn subtraction to addition of the opposite. So we have 0 plus -4. We're adding unlike signs, so we take the smaller, which is 0, from the larger, which is 4. So 4 minus 0 is 0. We keep the sign of the larger, which is the 4. So we are at -4. So what is the output value if x is 2? Then we have y equals 2 minus 4. 2 minus 4. Let's clear these annotations. Once again, we are subtracting. Therefore, we change subtraction to addition of the opposite. So we have 2 plus, and what is the opposite of 4? It is -4. Now we are adding unlike signs again. So we have 4. We're taking the smaller from the larger. So we have 4 minus 2, which is 2. And the larger, one with the larger absolute value, is 4. So we keep the sign of that original, which is negative. So therefore, our output here will be -2. -2. Y will be -2. And finally, let's take a look. If we use 4, we substitute 4 for x. Substitute 4 for x. When x equals 4, we have what? And we have y equals 4 minus 4. So what is the output value when x equals 4? So we have 4 minus 4. So in 4 minus 4, once again, it's addition of the opposite. Okay? Addition of the opposite, so we'll end up with 4 plus -4. 4 plus -4, or 4 minus 4, equals 0. So our y value will be 0. Now let's take a look at building the concept. Scarlett paid $10 to join a stamp collecting club. Each month that she chooses, each month that she chooses to receive new stamps, she must pay an additional $6. How can she use a function rule to find how much she will spend on the club if she receives stamps for 3 months, 6 months, or 12 months? Let X represent the number of months, so X is going to be our input value. It's going to be our independent variable, the number of months that Scarlett receives stamps, and Y is going to represent the total amount she will spend, or our output value, or our dependent variable. So the amount Scarlett will spend is going to equal the cost per month, which is going to be our X value, or our input value, times the number of months, plus the cost for joining. And that will give us our output value, or our dependent variable. So now we're going to input. If we put input 3 for X, if we purchase stamps for 3 months, what will we have? Well, we put 3 in for X, and what will we have? Our cost for joining, we have $6 because she's buying stamps. We're going to have 3 there for the X. Let's write that 3 in there so you can see it. Okay. And then our cost is $10. That's never going to change, so that's going to stay the same no matter what. We end up with what? 6 times 3, which is what? 18, plus 10. So our cost, or our Y value, or our output value is 28. Now what is this going to look like if we substitute 6? If she purchases stamps for 6 months, she has to pay $6 per month and the $10 entry fee, or what she paid to join the club. Okay? So what is her total cost going to be? $6 times 6 months, which is 36, plus 10, which will be $46. $46. Okay. And finally, how many months is she going to do at the end? She's going to do it for 12 months. So we'll put 12 becomes our X. Okay. We'll insert that 12 into our equation here. And we have, we have 6 times 12, which is what? 72, plus the $10 to join, which will be 82. If she purchases stamps for 12 months, she will spend a total of $82. $82. Input-output tables. You have the independent variable, which will be your X value. You input it into your function rule, and that will give you your output value, or your dependent variable. Okay, now let's move on to page 32. Let's work on the try it together. We're going to complete each input-output table. If you think you can do it on your own, then give it a try. But we're going to walk through this together really quick here. Which I know you guys, if we were actually sitting in class, that you could fly right through with me. And we're going to start with problem number 4. What is the function rule for this table? The function rule for this table is y equals 2x plus 5. Now we're going to evaluate this function rule for x equals 0, x equals 2, x equals 4, and x equals 6 to solve for our y value, or our output value. So x will be our input values, y will be our output values. We will use the input-output values later on to do some other things with. So let's take a look. Let's substitute 0 for the x value in our equation. What is our equation going to look like? Our function rule says y equals 2x plus 5. So we have 2. We are substituting 0 for x, and we are still adding 5. We use the order of operations to solve our function rule, solve our expression, as we always do. So we do multiplication or division first. 2 times 0 is 0, and 0 plus 5 is 5. So if x equals 0, our input value equals 0, our y, our output value, equals 5. Now we're going to input 2 for x. So if our input value is 2, what will our function rule look like? Well, it is 2 times x, so we have 2. We are substituting 2 for x times 2, and we have the plus 5. Once again, we follow the order of operations. We have 2 times 2 is 4. 4 plus 5 is 9. So our output value, or our y, is 9. Those of you who can't see that in your head, we will do that manually here. We have 2 times 2 plus 5, and I apologize, it's hard to write with this pen sometimes. First, we must do the multiplication, following the order of operations. So 2 times 2 is 4. We end up with 4 plus 5, and 4 plus 5 is 9. Okay? Clear that out. Clear that out too. Now, we are going to input 4 for x. Our input value is 4, or our independent variable. Going to put it into our function rule, which is 2x plus 5, so we have the 2 here. We are putting in 4 for our x value, and then we bring in our 5. So now we have 2 times 4 plus 5. So we have 2 times 4, that is a terrible looking multiplication symbol, times 4 plus 5. Order of operations tells us we must multiply first. 2 times 4 is 8. And we have 8 plus 5, and 8 plus 5 is 13. So our output value here will be 13. And finally, we will input 6 for x, so we'll substitute 6 everywhere we see x in our function rule. So we now have, our new equation will be, our new function rule will be 2 times 6 plus 5. Once again, we follow the order of operations. We have 2 times 6 plus 5. So 2 times 6 is 12. And we have plus 5. And 12 plus 5 is 17. So our output value, or our y value, will be 17. We've evaluated our function rule, or our expression, using our input variable, which in this case was 6, and our output, or our dependent variable, will be 17. And now let's take a look at problem 5. Problem 5, we're working with division. Our function rule is y equals x divided by 2. We're working with division now. So we're going to evaluate our function rule, or expression, for our input values will be what we're going to substitute for x. Our input values are going to be negative 2, 0, 2, and 4. So we're going to start with the first one. We're going to start with negative 2. So if we input negative 2 everywhere there's an x in our equation, our new function rule will look like this. Negative 2 divided by 2. And that's going to equal what? We know that 2 divided by 2 is 1. And a negative divided by a positive is negative. So our output value will be negative 1. Very good. Negative 1. Let's continue our input-output table. We're going to input 0 for our x value. So our new function rule, our expression, will be 0, because we substituted 0 for our x, divided by 2. What is 0 divided by anything is always 0. So our output value will be 0. Now we're going to input positive 2 for our x value in our function rule. So we will have, our new expression will be 2 divided by 2. We know that 2 divided by 2 is 1, and a positive divided by a positive is positive. So our output value, or our y value, will be positive 1. And finally, we will input 4, positive 4, for the x. So our new expression will be 4 divided by 2. 4 divided by 2 is 2. A positive divided by a positive is positive. So our answer will be positive 2. So what have we done today? We've looked at input-output tables and how to use our independent variable. We've inserted our independent variable into our function rule to solve for our dependent variable. Or we've inputted x, use our input variable x to solve for our output variable y. We're going to use this information to do some further practice on pages 33 and 34 at a later time. But that is input-output tables.